Cisco Certified Network Associate Day 22. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. Like we discussed in our last video, we are extremely pleased to announce that we would be upgrading the series to the CCNA version 3, right? So whatever you have learned or watched in the last 23 videos is absolutely relevant, right? And we will be continuing from where you are and updating the series to add all the CCNA topics of CCNA version 3, which is the 200-125. So nothing to worry, but whatever you watch is absolutely relevant, and we would be continuing from here. Like we said, we would be first doing the CCNA, that is ICND 1, that's 100-105 exam, right? So we would be, in the next few videos, we would be covering all the topics that is relevant for ICND 1, and you can go ahead and take the exam. And after that, we would do ICND version 2. End of this entire series, you should have all the knowledge required for 200-125 exam, right? That's something I'm going to guarantee you. So if you follow exactly what we explained to you and then you do practices, I think there's no reason why you should not be able to clear your CCNA 200-125 as an exam, or if you do the ICND 1 and ICND 2, right? So without wasting much time, let's get straight into today's class. Right, so what are we going to look at today? We're going to look at three things. We're looking at this counting to infinity problem in RIP routing. We will look at split horizon rule and the route poison, right? What is counting to infinity problem in RIP routing, right? To understand that, let's do some diagrams. Let's assume we have router 1 here, router 2 here, and router 3 here, right? And they're connected. Let's put IP addresses. This is 192.168.1.0/24. This is 2.0/24. This is 3.0/24 and 4.0/24, right? When I say 2.0, it is 192.168.2.0, right? So I just didn't have, right? So that is this is the network we have, and we're only going to look at this one route, 192.168.1.0. So in route 1, this route is, the routing table should have 192.168.1.0 with a hop count of 0, right? This is how the routing table at R1 would look. In R2, the same route would be at 192.168.1.0 with a hop count of 1, right? So we know from what we know in our last video that hop count keep increasing, right? So when R2 sends update to R1, R1 will add, right? So R1 has this route accessible at 0 hop count because it's directly connected to R1. When it sends an update, which it sends as part of routing protocol, RIP, it sends an update we learned in our last video, every 30 seconds they send an update to each other, right? Every 30 seconds they send an update to each other. So when R2 gets an update which says 192.168.1.0 is available with a hop count of 0, it just adds 1 to it, and it says, okay, 192.168.1.0 is accessible to me with a hop count of 1 through R1, right? This is how normally the routing updates are done, and how the routing tables are populated in each other's. Now let's assume a situation where this link breaks. So right, so R1 had access to 192.168.1.0 and now it does not have access. At the same time, R2 sends an update to R1 saying that 192.168.1.0 is available to me at a hop count of 1. Now R1 looks at that update and says, brilliant, I just had access to 192.168.1.0, but I lost access to it. But R2 is telling me that it has access to 192.168.1.0 with a hop count of 1, which means to say that I need to update my routing table with the value, with a hop count value of 2, right? So he's happy, everybody's happy. R1 sends the update to R2 saying that Okay, I have access to 192.168.1.0 with a hop count of 2. R2 looks at that update and says, okay, earlier you told me you have access to the same network with a hop count of 0, but now since you're telling me you have access to this route with a hop count of 2, I'm going to update my routing table to 3, right? So next time R2 tells R1 about this update, R1 updates it to 4, and R2 goes to 5, then it goes to 7, this goes to this goes to 6, 7, and it goes on. This problem is known as routing loop, or which in RIP it is called as counting to infinity problem. So basically that route 192.168.1.0 is not available now, but R1 and R2, and because of that all the routers in the network starts believing that this route is still accessible by a loop. Basically each other, they are lying to each other, right? This is a problem. This problem needs to be sorted out. So how do we sort? There are two ways we sort, two mechanisms, that is the split horizon rule and route poisoning. Before we look into that, let's look at a network that we're going to look at today, and let's look at the updates and what are the things that it does, right? So this is the update. This is the network where we have 3 routers. So this is R1, this is R2, and this is R3, right? R1, R2, and R3. This computer is 192.168.1.10. This is 4.10. 4 denotes, this is up to you. What I have done is 4 denotes 4.0 network, right? This is 1.0, this is 2.0, this is 3.0, and also the IP address that I've given to the routers are 1.1 because it's router 1, 2.1 because it's router 1, 2.2 and 3.2 because the last octet 2 denotes the router number, router 2, and 3.3 and 4.3 denotes router 3, right? And I've given the last octet 10 for the computers, both the hosts, right? You can follow anything, it's up to you, but I have followed this. It becomes easy for me. Now let's configure this in Packet Tracer, right? So I have used 2911 routers, so I've used 3 routers. I've according to our diagram, I have configured the IP address in both these hosts. Switches, you don't have to really do anything because all of them are in VLAN 1, so it's going to work out of the box. 2911 has gigabit Ethernet ports, right? So what I'm going to do is, to make it easy for you, I am going to give these running config of these 3 routers. You can get it on our website nwking.org, and you can go to resources. At the moment this is not updated, but by the time you see this video you will have all the days updated, and like you have the workbook here, you'll have day 22, you'll have the router 1, router 2, and router 3 configurations, right? What you could do is you could just go open router 1, copy, go to Packet Tracer, click on router 1, right? It says no, enable configure terminal. You can go here and just copy paste it, right? Whatever you copied there, just paste it here, and your router 1 will be configured. Similarly, router 2, you say config. Now, this is the best part about Cisco. You can just copy and paste. To make it easier, I'm going to add 2 more lines on these things, right? By the time you get this downloads, I would have corrected all these things, so you don't have to do it. So it'll be enable. These are the 2 commands that we have to configure terminal, right? Which I just typed. You don't have to type if everything is like this. So you can go here, go to router 2 and say no. Once you're here, you can just copy paste here and all those things. So if you see, router 1 has been configured. Similarly, router 3, I'm gonna just add those 2 commands, that is n and configure terminal, copy, come back to router 3, and just say no, copy paste it here, everything is done. So router 1, router 2, and router 3 has been configured everything is working. So just to make it easy, I'm going to give access to these running configuration, right? If you're using any other router, just make sure that the interfaces are right. In this case, like I said, it has gigabit Ethernet, right? So you will have to maybe change it to fast Ethernet or something if your device has fast Ethernet, right? Brilliant. Now what's the problem? Why is it still in red? I have not done this here, so let's use this as a troubleshoot. Let's see what's the problem. The first command, I think what you should use, this should be the Swiss knife for troubleshooting. That is show IP interface brief, right? And yeah, we have a problem, right? All administratively down. That means I think we have forgotten to give, right, in the running configuration I have forgotten to give this command which says no shutdown. What I'm going to do is, by the time you get this, no shutdown would be part of that, right? So but I'm going to quickly do no shut here, configure terminal interface range G0/1 0/01 no shutdown. That means this should be up. Again exit interface range G0/0 no shut. Configure terminal interface range G0/01 no shut. Brilliant. So all these three routers are up and running now. Right, so let us get these devices. So router 3, router 2, router 1. I'm going to quickly tag these windows, so it becomes easy for us to monitor them. And I'm going to debug. So now at the moment RIP routing protocol has been configured on all these three devices. So let's do debug IP RIP. That means I'm going to debug all the RIP updates that comes through. Debug IP RIP and debug IP RIP, right? So whenever there is a RIP update that comes through here, we will be able to see it, right? So RIP updates are coming. I think this device just sent a RIP update, right? All the devices have got RIP update. So just let's do undebug all, right? You could just say u all, which is nothing but a short form for undebug all, u all. Right. Anyway, again, this is like we have discussed this is a DNS problem. It is, domain server it's looking up. This is definitely part of in CCNA v3 we have a lot of DNS things, so we will definitely come back to that. I've shown you how to disable this domain server lookup, but we will come back with another video. We will be filling into some information that we did not cover so far, and one of them is going to be DNS, which will come back, right? So don't worry about that. Let's look at this. So how does it work? How does RIP updates work? When we start the device, so let's go back here, right? When we start the device, router 1 has two connected interfaces, that is 192.168 1.0, 192.168 2.0, and both of them are connected to this. That means in the routing table you will have C and C. I'm going to just change the color just to be easy on the eyes, right? So it should have C and C, right? So you'll have C and C, both of them are connected, and they will have a hop count of 0, because the metric used in RIP is hop count, so it has a hop count of 0 because they are all directly connected. Similarly with router 2, you have 2 directly connected, and router 3 you have 2 directly connected. When the routing update goes from router 1 to router 2, what does it send? It sends an update about 192.168.1.0 and 192.168.2.0, right? And since router 2 already knows about 2.0, it is only going to take update of router 1.0 and it is going to populate this 1.0 here, right? So what does it say? 192.168.1.0 is accessible through 192.168.2.2 or nothing but the fast Ethernet 0/0 interface with a hop count of 1, right? Why? Because it sent an update with a hop count of 0. It is adding 1 to it and it is going to say hop count of 1. Similarly, when this device sends that same 192.168.1.0 to router 3, it is going to put that same interface or same network 192.168.1.0 accessible through 3.3 or f0/0 interface with a hop count of 2, right? That's how routing updates work. To avoid the looping or the counting to infinity, RIP has a mechanism called split horizon. Split horizon just says this: do not send update about a network or a route on that interface through which you learned that, right? For in this case, let's say router 2. Where did router 2 learn about 192.168.1.0? It learned on this interface, on f0/0. That means when router 2 sends out updates to router 1, it will definitely not send out on f0/0 updates about 192.168.1.0. It will only send 3.0 and 4.0, because 2.0 also it will not send, because 2.0 was also learned from f0/0, right? Because it is connected to that network, it is connected on f0/0. So when router 2 sends update to router 1, it is only going to send updates about 3.0 and 4.0, because these two, 3.0 and 4.0, were learned on f0/1, right? 3.0 is connected to f0/1 and 4.0 was learned through f0/1, right? So it is only going to send these two updates on this f0/0. That is the simple rule of split horizon, which means to say, do not send updates about a route on the interface from which you learned those in the first place, right? Very simple. That's a rule that is there to prevent the counting to infinity problem or the routing loop. Now, so if you go back to packet tracer, you will see that router 1 is receiving update from 2.2. What are the networks it is sending? It is sending 3.0 and 4.0. It did not send 1.0 because router 2, this is router 2, it's receiving from router 2, right, 2.2. Because 1.0 and 2.0 networks were learned from this very interface, right? So it's only sending up updates about 3.0 and 4.0. Now router 1 is sending, now it is sending updates, right? Where does it send? It sends it to the multicast IP address. It doesn't send to broadcast IP, it sends to a multicast IP address of 224.0.0.9. So multicast IP is like a frequency, right? We have FM, like let's say FM 91.9. Now only devices, FM signal is there around us, but only devices that is tuned to 91.9 is going to get radio frequency or radio songs playing on FM from that frequency, right? So similarly, routers that is participating in RIP will tune themselves to listen to traffic on 224.0.0.9, right? So router 1 is sending update to this multicast IP address on gigabit Ethernet 0/0 interface, right? On that interface, so if you go back here, it is sending update on this interface. On this interface, it can't send 1.0 updates because it learned 1.0 from that. It can only send update about 3.0, 2.0, 3.0 and 4.0. That's exactly what's happening. So it sent update about 2.0, 3.0 and 4.0. And on gigabit Ethernet 0/1 on this interface, right? In this case, it says fast Ethernet. Don't worry, it's actually gigabit in our example. So on this interface, it is sending update only about, it can't send 2.0, 3.0 and 4.0 because it learned all those three on this interface. So he can only send update about 1.0 on this interface, right? So on fast speed gigabit Ethernet 0/1, it is sending update only for 1.0, right? So that's it. Now let's do this. Let us see what happens if we, let's assume this network breaks for some reason, right? So immediately what the router 1 does is a mechanism called as route poisoning, right? Route poisoning is immediately when a network becomes unavailable, create the hop count, right? Update the hop count of that network to 16. Like we know 16 is inaccessible, so that device cannot be reached. It creates that update and immediately, it doesn't wait for the 30-second timer. There's no update timer. There is a triggered update. Immediately it sends a triggered update. So I'm going to just change the color for a triggered update. This is going to be a blue. It sends a triggered update to router 2 and tells network 192.168.1.0 is accessible with a hop count of 16, which means to say it is inaccessible, right? This is called as route poisoning. Immediately when router 2 gets that, it updates its routing table to update it to route 16, and it sends the same update to router 3, which also updates its routing table to 16, by which time all the devices participating in a RIP will know that the network 192.168.1.0 is not accessible to anyone, right? This prevents the counting to infinity problem, and nobody, all the routing table of all the devices gets updated. This is called as convergence. Convergence means all the devices updates its routing table to the current form, which is without the 192.168.1.0. right? So these are the things: one, counting to infinity problem, which we discussed, and what is split horizon rule, and what is route poisoning. I'll show you a couple of troubleshooting commands as well. So of course we know show IP interface brief. We can look at another command, which is show IP protocols. So this is something you can run on your routing protocol, devices that has routing protocol, dynamic routing enabled. It will tell you that routing protocol is RIP. Updates are sent every 30 seconds, next due in 8 seconds. Invalid timer is 180 seconds, hold down timer 180 seconds, flush timer is 240 seconds, right? These timers can be changed, but it is definitely not relevant to your CCNA. As you go higher, like CCNP, CCIE, we can work and play around with the timers, but for CCNA these are your default timers, and it stays at default timers. Filter lists, we are not going to do filter lists for RIP. Redistribution also is definitely not part of your CCNA. The redistribution is when you have more than one routing protocols on, let's say, interface F0/0 has RIP, F0/1 has OSPF. How these routing protocols communicate with each other, right? So how does RIP take routing, redistribute it to OSPF, and how OSPF takes it and redistribute it to RIP? That is redistribution, definitely not part of your CCNA. Interesting topic, definitely higher level. Auto summarization, we discussed what auto summarization is in our last video. Yeah, so basically, and the default distance, admin distance, is 120. We need to discuss that. Show IP route, let's discuss that. So router 1, like we know, 192.168.1.0 is directly connected. It says here directly connected. 2.0 also is directly connected. It learned two networks using RIP routing protocol. It is denoted here by R, which says it is learned through RIP. Like if you look at the codes, it says R is for RIP, right? Now it says 192.168.3.0/24 is accessible via 192.168.2.2. that is nothing but gigabit Ethernet 0/1, right? 4.0 also is accessible through gigabit Ethernet 0/1. It learned that from 2.2. These two information are critical. The first 120 is the admin distance. Admin distance is the believability of a route. And the next information you see here is 1, which is the hop count, which is the metric. For RIP, the metric is hop count. But if we look at other routing protocols like OSPF and EIGRP, it has its own metrics, which we will discuss when we reach them. But for RIP, the metric is hop count, so that is why it says 1, which means it is accessible in 1 hop count. For 4.0 is accessible in 2 hop count. Now what is AD? Admin distance, like we discussed. It's a believability. So if, let's say for instance, there is another route, a static route. A static route has a believability of 1, which means it's the best. The lesser the value is better. So if there is, for 192.168.3.0, RIP says you need to go via gigabit Ethernet 0/1, and let's assume there is another route for 192.168.3.0, the same network, but with a admin distance of 1, which is static route, and it says it needs to go via gigabit Ethernet 0/0. This device will pick that and send any traffic to 3.0 via gigabit Ethernet 0/0 because that has a better admin distance, and better is always lesser in routing protocol. So less is better. So RIP is 120, which is one of the worst admin distance or worst believability as routing is concerned, right? So that is admin distance. Another troubleshooting command that you can look at is show IP interface gigabit Ethernet 0/1, right? So you can look at it. It says what is the IP address given, broadcast for this IP address, MTU values, blah blah blah. This is important. Split horizon is enabled, right? So you might have a problem where split horizon is disabled, right? Maybe a problem, or I mean part of the exam, maybe they might disable it and ask you what's the problem. So this is where you check if split horizon is enabled for that interface. By default, split horizon is enabled, right? These are the troubleshooting commands that you can look at, right? So I think we have discussed what we need to discuss in RIP. So those are the advanced topics of RIP. I think we have covered pretty much everything that we need to cover with RIP. We will be very soon looking at other topics. So like I said, I would be updating all the topics to to be relevant to the 200, 125 or ICND1 and ICND2. So maybe another few more videos. We should be completing ICND1 topics, and I will let you know when you're ready for ICND1, and I will be going back to some of the fundamental topics and updating it relevant to the new syllabus of CCNA v3. So thank you so much for joining me today, and I'm sure you would be joining me back in the next video. Thank you so much. Bye bye.